Hey everybody, welcome back to another video. My name is Zach. I do LeetCode and tech videos. Check out my channel for more LeetCode videos. I'm gonna start pumping them out. So today we're gonna be doing LeetSum 4. Input is a BST number 653. This is very similar to the other two sums, and I'll be showing you guys how to solve it. Today I'm gonna be solving it in C++, but if you guys want to see it solved in Python, Java, Kotlin, Swift, just let me know down in the comments, and I'll go ahead and show you guys how to do it in that language. C++ is my preferred language. So, with mostly any type of two-sum questions, the way you want to approach it is you want to look through each element, and then you want to see if you can find a conjugate, right? Something where it's the complement that's needed to reach K, or your target, right? And so the way how we can do this is through, since we only need to find a Boolean, we just need to return a Boolean. We don't really need a hash set. We don't really need a hash map to keep the indexes. There's some other questions, some other two-sum or three-sum questions which ask you for the index. Then you would want to find, you'd want to hash the value, the complement with the index. But since we just need to return a Boolean, we can go ahead and use an unordered set. And this is going to hold our values, right? So it's going to be integer values, and we're just going to name this comp for complement. And so we're going to have to either use so depth first search or breadth first search. So I'm going to go ahead and show you guys how to do it with depth first search, but you can always use breadth first search, where you just go level by level, level order traversal versus in order or pre-order or post-order traversal. So usually how I do this is I just write a void function. Actually, we can just make it a bool function and return it in the main function. Let's name it explore. We just want to explore the tree recursively, and here we're just going to return if this is true. Explore. So we're going to pass in the roots, we're going to pass in our target, and then we're going to pass in our complement, our set, right? And then here for the function signature, the root is obviously going to be a tree node, root, and then we're going to need an integer target. That's what we're looking for, and then we're going to pass in by reference the unordered set. And this is the set which is going to be holding the complements of every digit that we've seen before. So the way that you pass that by reference to C++ is with an ampersand, and then we'll just name this comp, right? And so if we don't have a root, if the node is invalid, this is our kind of our base case. Once we hit the leaves and we haven't found the complements yet, or the two things that sum to it, that sum to our target, we're just going to want to go ahead and return false, right? And then, but if root comp dot find root val, so if we've seen a digit whose complement is inside the complement unordered set, and that complement is our current root val, that means we found the two values, right? And we can just go ahead and return true. Since the unordered set.find returns an iterator, we're gonna have to, it's not equal to comp dot end, right? So dot end is an iterator to the last, to one past the last element. So if it's not one past the last element, if it doesn't exist, it's gonna the iterator is gonna be comp dot end, the ending iterator. Otherwise, we're gonna go ahead and return true. And then now, so now that we know that the root is valid and that we don't have the complement, we haven't seen a number before, that's the complement for that, we want to go ahead and push the complement of this value into our unordered set. I'm going to push target minus root val, right? And then now that we've pushed it, we want to return if the right node or the left node are valid, right? Have the complements. So we're going to return for root left target. We're going to go ahead pass comp in again, or the right subtree. There we go. And there you go. So that should give us a correct answer. Perfect. Let's go ahead and submit it. Solve this one today morning. Perfect. The memory usage is a bit heavy, but it's pretty fast. All right. If you guys have any more questions, let me know down in the comments.